Hello and welcome to the Chandara Academy. Swakon Mokan Chandara Academy. In today's video, we are going to calculate the following limits. This time, limits in plus or minus the infinity. We will have limits of quotient of polynomials, and we will see how to solve them very easily. A is the limit when x tends to plus the infinity of x to the third minus 3x plus 1 over 2x to the third minus 4. So what we want to identify here is what is going to be the strongest term at the top and at the bottom, because of course this thing will be the form infinity over the infinity, but this thing is a non-defined form as well. We have to work this out a little bit. And in plus or minus the infinity, when you have polynomials, the ones who are going to win are the polynomials with the higher order. Here we have an order 0, here we have an order 1, and here we have an order 3. At the top, this will be the order 3 that will win. Same thing at the bottom, this will be 2x to the third that will win. So now, how do we really calculate the limit? We've got for all x in, let's say, this thing is f of x, in the domain of f, we've got f of x that is equal to, we will factorize by the highest term, so x to the third at the top and x to the third at the bottom. And now we just have to rewrite it. What do we have for x to the third? We have 1 times x to the third plus what? Plus minus 3 x divided by x to the third plus 1 divided by x to the third. So you can simplify it if you want. So here x divided by x to the third is equal to x squared. Same thing at the bottom. What will we have? We will have 2 minus 4 over x to the third. And now, what do we have here? We can simplify the x to the third together, and we are left with 1 plus minus 3 over x squared plus 1 over x to the third over 2 minus 4 x to the third. And we know that for all power that are greater than 0, for all power that are greater than 0, 1 over x to this power tends to 0 when x tends to plus or minus infinity. And this implies that 1 plus minus 3 over x squared plus 1 over x to the third over 2 minus 4 over x to the third will tend, when x tends to plus the infinity this time, to 1 plus 0 over 2 plus 0. Perfect. This will be equal to 1/2, and this is our first limit. A is equal to 1/2. If you've got like a little bit more experience, you can identify it like first thought. You have 1 over 2 because these are the strongest terms. 1 over 2, you know that the limit will be 1 over 2. Same thing here, I know that the limit will be 1 over 2 as well, but we still have to prove it because we are in mathematics, we want to prove everything, and this is like the goal of your chapter, to learn how to prove this thing. Same thing, so let's call this g of x for all x in the domain of g of x is equal to x squared plus x plus 1 over 2x squared plus 1, which is equal, we factorize by the highest term at the top and at the bottom. X squared times what? X squared times what? Here we have obviously 1 plus x over x squared, which makes 1 over x plus 1 over x squared. Here we have 2 plus 1 over x squared. We can simplify both x squared together. We have 1 plus 1 over x plus 1 over x squared over 2 plus 1 over x squared. And we know that the limit when x tends to minus the infinity of 1 over x is equal to the limit of 1 over x squared when x tends to minus the infinity, and this is equal to 0. In conclusion, g of x will tend to 1 plus 0 plus 0 over 2 plus 0, which is equal to 1/2 as well. 1/2 when x tends to minus the infinity. This is another way of writing limit of g of x. So two ways of writing when x tends to minus the infinity is equal to 1/2. And we have solved our second question, and so our whole exercise. I hope you enjoyed the video and learned how to deal with those infinity limits. See you soon. Bye.